Today I'm going to continue with the prerequisites of the polynomials. One prerequisite which we are yet to see is graphs. So how and why we need graphs? Now before going that, we have to consider why we need graphs. So we represent the graphs like this. You may have seen these types of arrows, but why we generally represent like this? There's any particular reason? So I'm going to start with an example of the application. Consider there is a colony with the buildings as follows. For convenience, I have placed the buildings square shaped buildings. Generally, buildings are considered it as square, and there's also two roads like this connecting this colony. And these are all roads, empty spaces. Consider it as rows. So house number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now the question arises that how we will identify these houses. So how I will identify these houses? Now since if we see from top, we are seeing from top view. So 1, 2, 3, 4, 5, 6. I have labeled it. It is very easy to identify. But suppose imagine a person or a car or a bike or a person visiting this colony for the first time, and you want him to go to house number 6, say for example house number 6, and these are the available roads. So how you will say to him and how you will give the address correctly so that he goes to house number 6? There are so many routes. He can go like this, or he can walk this way and go like this, or he can go up to here and then take like this. I will represent it by arrows, his path. There are so many paths possible here, as you can see. But what we need is that the person should reach by using possible shortest path. Uh, I mean the shortest path, not that you can go like this, because we cannot go from buildings. This is obviously not possible. I meant that to the roads, what is the shortest possible path? So this is the reason why we need graphs. In this application, we need graphs because if I assume that there are coordinate system, this is a origin. This is origin. I will start here 1, 2, 3. 1, 2, 3. This is a number line, as you know. Number line 0. This is origin or 0, and this is -1, -2. If I represent it like this, and also this is one more axis which is perpendicular to this is called as x-axis, and this is called as y-axis. Similarly, above the 0 it will be 1, 1, 2, 3. So now I can consider these houses are placed like this. I can consider that these are the houses. So totally there are 10 houses. So this is house number 6. So how I will label house number 6 is, now I will rub all the remaining houses so that it will be easier. So house number 6 is at house number 6. This is a person standing at origin. He is at road. So now you may see, since here there are no buildings, you may say we can go directly like this. But as we know that from this diagram, there are so many buildings here, and this is the shortest route, but this is not possible. So how we will go there? So first you can either go like this, the person has to go like this up to 3 units. Then again after that, after coming to x equal to 3 point, this is x equal to 3 point, and the value of y here is 0. From here he can go upwards up to, he will move in the y direction, that is upward direction, from 3 3 then 1 2. Here y is 0, y equal to 1 and y equal to 2. Then he will reach from x equal to 3, x will remain 3 but y will change from 0 to 2. This is the coordinate. So the value of x and y can be represented as follows: brackets x comma y. So here the house number 6, I will represent it as x value is 3 and y value is 2. There is also one more route possible. The person can go first in y direction up to 2 units, then again take in x direction 3 units. So this is also possible, and this is also, both the routes are equivalent. This is a simple example of a graph, and I'll continue with it in the next video.